Hello everyone, this is INE Foundation Lab 3 and section 2.4 spanning tree. Okay, let's review spanning tree types and I will come back and conclude this section. Okay, first type is STP or spanning tree protocol. It is IEEE 802.1d standard. It calculates a single spanning tree for all VLANs. In other words, we have one spanning tree instance for the entire switched network, regardless of number of VLANs. STP consists of two parts. STP's bridge ID or BID consists of two parts. One is bridge priority and the other one is MAC address or system ID. Cisco has created its own STP. It is called PVST Plus or per VLAN spanning tree. It is Cisco proprietary. PVST Plus is IEEE 802.1d STP standard implemented per VLAN. It is default on Cisco switches prior to RS version 15.2. It calculates the topology for each VLAN, and it uses different root page for each VLAN. We have different root page election for each VLAN. PVST Plus, PVST Plus BID or bridge ID consists of three parts. One is bridge priority plus system ID extension plus MAC address or system ID. And the BPDU is sent for each VLAN and they are processed separately by the switch as it runs STP instance per VLAN. Okay, let's see differences between PVST and PVST Plus. PVST uses ISA trunk only. It sends its own proprietary BPDU and it is not backward compatible with STP, standard STP. On the other hand, PVST Plus supports 802.q encapsulation, .1q encapsulation. PVST Plus sends 802.1d standard BPDU with its own proprietary BPDU. PVST Plus is backward compatible with the standard STP. Then we have RSTP, or Rapid Spanning Protocol. It is IEEE standard 802.1w. It has new port state and port rules. Port rules are alternative and backup, and port state is discarded. I will explain these ports later. And RSTP has faster convergence time. Then we have Rapid PVST Plus. It is Cisco proprietary. Rapid PVST Plus is the IEEE 802.1w RSTP standard implemented per VLAN. A single instance of STP runs on each configured VLAN. And each Rapid PVST Plus instance on a VLAN has a single root switch. We have single root switch election for each VLAN. We have MST or multiple span tree. It is IEEE standard 802.1s. MST maps multiple VLANs to an instance. For one STP for multiple. We have one STP for multiple VLAN. And it reduces number of span tree instances, and we can use instance and map VLANs to each instance. This is the difference between MST and other STPs. Okay, RSTP port state. Let's compare STP and RSTP port state. STP port states are disabled, blocking, listening, learning, and forwarding. In RSTP, we don't have blocking, and listening. Instead, we have discarding. We have discarding, learning, and forwarding. This is RSTP and STP. And RSTP port rules. Let's compare STP and RSTP port rules. STP port rules are root port, designated port, the search. All ports on root page are designated port and are in forward instance. Keep in mind that this what is designated port. We have root port, designated port, and block port. This is port rules of STP. In STP, but we don't have block port or blocking port. Instead, we have alternative and backup. We have root, designated, alternative, and backup. We don't have blocking port in STP. This is why it has faster convergence time. RSTP has faster convergence time. Okay, edge port and link type. This is important to understand to come for this section in INE. What are edge port? In edge port, it is 802.1d portfast feature. It skips the listening and learning stages and transition directly to a forwarding state. If we configure port as portfast, it will become edge port, and we don't have listening and learning stages. It is STP port. We don't have listening and learning. It is going directly to forwarding state. We have blocking and forwarding state. An edge port that receives a BPDU immediately loses its edge port designation and becomes a regular STP port. This is the edge port. If you configure port as portfast, it will become edge port. And to configure all interfaces in switch as portfast, we can use this command. Spantry portfast default. If you configure this command on switch, all ports of that switch will become portfast, and they will become edge ports. And let's check link type. Link types are half duplex and full. We have two types of link type. One is half duplex and full duplex. If you come for full duplex, it will become P2P, and if we come for half duplex, it will become shared. Half duplex is shared, and full duplex is P2P. Okay, let me add this here. Okay, there are two types of link type. One is half duplex and full duplex. If you come with full duplex, it will become P2P, and half duplex is shared. RSTP can only achieve a rapid transition to a forwarding extent on edge ports, and edge ports are portfast, and on P2P or full duplex links. The link type is automatically derived from the duplex mode of the port. Okay, RSTP forwarding state is enabled only on edge port or portfast and full duplex links. RSTP assumes that links configured as full duplex are point-to-point or P2P, and links configured as half duplex are shared. Shared links are not eligible for RSTP fast transition into forwarding state. In other words, to disable RSTP forwarding state, we can configure either this command or this command. Span tree link type shared, or change the duplex mode to half duplex by duplex command. This is how we can disable RSTP forwarding state, either by span tree link type shared or change the duplex mode to half duplex. And for configure RSTP, we can use span tree mode, rapid PVST, and this is our verification command: show span tree VLAN number and show span tree summary. There is one command I want to mention. This is show VLAN ID command. The show VLAN ID command is in Cisco switches displays all interfaces that are carrying the VLAN, including both access and term ports. This is why you might see more interfaces than you expect. If you type show VLAN ID command, you may see more interfaces that you have specified as access or term. This command displays all interfaces that are carrying the VLAN. Okay, this is now, let's configure this section. Okay, we have to configure 802.1w between switch 1, switch 2, switch 3, and switch 4. This is RSTP, as I explained before. RSTP. This is 802.1w. Okay, let's see our switches. These are switch numbers. Switch 2, switch 3, and switch 4. Let's do show spanning tree VLAN number 1. Okay, then this is span tree enable protocol is IEEE. This is default. We have to configure. This is all because we have all ports are designated. This is root switch. All is designated port, and those are all in forwarding state. Okay, let's configure. Config T, and I type span tree mode MST, PVST, and rapid. We have to configure rapid PVST. Rapid PVST. Rapid PVST. Config T and rapid PVST. Okay. This is 801W. It is RSTP. of PVST. Okay, use a single command on switch 2 and switch 3. Ensure that any port configured as a static access port automatically transition into an edge port. Okay, what it is asking is that if you configure static access port, it automatically transition into edge port. What is edge port? If you configure port as portfast. It says we have to configure all interfaces of switch 2 and switch 3 as portfast by single command. We can use SPIN-T portfast default. This command will make all interfaces of our switch as portfast. On switch 2, SPIN-T portfast, and we have edge, network, and normal. I will type edge here. This edge means the port will become portfast. Edge for all access. This is our edge default. Spanning tree portfast, edge, and default. This is I can add. This is new command as switch. Spanning profile edge default. Edge default. And I have to configure this on switch 2, not switch 1. No span to edge default. Okay. Switch 2 and switch 4. On switch 3. Switch 2 and switch 3. Switch 3. Okay, if I now do show run, this is SPIN-T portfast edge default. Let me show. I'll remove this. Do show run. Okay, I don't have that command here. On switch 2, I have this. Okay. On switch 3, switch 2. SPIN-T portfast edge default. This will make all port as edge port. I can verify this. We'll do show VLAN, do show SPIN-T VLAN number 1. So okay, down. This means this is full duplex mode. And I can verify this by do show spanning tree summary. Do show spanning tree. If I do spanning summary command, as a portfast default, I can see portfast default and is H. If I do here, to show spanning tree summary command, the portfast default is disabled. On switch 4 is disabled. To show spanning tree summary, portfast default is disabled. But on switch 2, let's check switch 3 either. To show spanning tree summary command, and portfast default is H. On switch 2 and switch 3, portfast default is H. This is done. And last part, disable 802.1W rapid transition to forwarding state on trunks between switch 2 and switch 4. Okay, on switch 2 and switch 4, we can verify to show CDP neighbor. Switch 2, this is switch 4. Do show CDP neighbor on switch 2 and switch 4. We have to turn, it means disable 802.1W rapid transition to forwarding state on switch 4. It means that we have to configure link type. We have to configure link type as shared. We have to configure link type as shared on trunks between switch 2 and switch 4. Okay, switch 2 and switch 4. Switch 2 and switch 4. This idea. Okay, interface range, Ethernet 0 and 1. How can we configure link as shared? We can configure either by spanning tree link type shared or change duplex mode to half duplex. Okay, let's change spanning tree link type shared. Spanning tree link type shared. We have shared. It means it will make up, or we can change link type to half duplex. On switch 4, interface range Ethernet 0 3 1 spanning tree link type and share. That's it. And we can verify do show span do show spanning tree VLAN number 1 and the links between are not shared. Let's check here. Do show spanning tree VLAN number 1 and links between these links are shared. That's it. This is our part of section. This is our section, and I hope you have enjoyed this video, and thank you for viewing.